नहीं नहीं इसको आगे रखो क्या है चल रहे हेलो हेलो चेक चल रहे
Good afternoon, respected Professor Vidya and campus chief, madam, and sir and faculty members of Bilaspur Government College, and my friend and colleague, Dr. Aman. It is my privilege to be here today, and I would like to say good afternoon and thank you very much for my invitation. And there were many hurdles while I came yesterday. Let me share that. Like this, yeah. Is it audible on the back? Yeah. Okay. I was about to meet my boss to Bilaspur yesterday. Although I didn't miss that was very great. And I came in a prepaid taxi from the airport, and he drove me. I have luxuriously 3 hours from the airport to that Mandukatila. And I was very confident that I will catch the bus. But the taxi driver, after reaching around metro station, he stopped the car and said that, "Sir, I cannot take you up to the Mandukatila because of the traffic." That is what he said. Long before, it is 1.5 hours remaining. And I said, why he said that thing? And he also told me that if, as a foreigner, you are safe in Delhi, that is because of your good taxi driver. That is what he told me. And I realized that was very true. And I am safe because of the good taxi driver there. And I thank you for a great Indian nation who helped me to arrive on time. Otherwise, I would walk around this time. So I will miss all the events after it. And he took me on the metro, and he took me, and he also purchased the ticket for me, and then he teach me how to go because I have never gone in metro station because it's in India before. So I went and I took a train up to the Vidhan Sabha, and from there he told me to take a cab up to the Mandukatila, the Indian petrol station. So I was like 15 minutes time ahead of time because of taking metro train. Okay. So that metro train is related area. Metro train is related. And by the way, this is the Supercomputer at California University. And I will tell a lot of stories about this. And here is a metro train. This compares our computer and supercomputer. And on the down sector, there are two rice planting time. In this picture, only a lady is harvesting. She is doing everything, taking rice plants from the nursery and digging. Other trees at the moment not digging, she is planting. One person doing everything. That is our laptop operation. And in the next figure, there are 10 persons planting the rice, and 5 are on the nursery, and one distributing those stack of rice, and one here just digging those fields so that a coordinated work. And in principle, this work and this work is 10 times faster. Okay. So if we have like 100 persons planting, the ratio of open is 100 times faster. That not happen sometimes because part of the time is of expert doing task, they will communicate each other. Suppose the boundary this person is planting close to this person also. Okay. So they have to communicate each other. That whether she should plant that part or she should plant on that part. So there will be communication. And if we increase the number of workers, the communication budget, let us say, in more formal way, communication budget will also rise with. Okay? And that will decrease the work efficiency. And exactly the same thing happens in supercomputer. And the same thing happens in our system also. Suppose we have 10 member family, although that is rare in Nepal and India mostly. One person can cook rice for 10 people. Okay. But if there are 100 people family, like big communal family, like mostly in a tribal places, so one people cooking is very inefficient. At least 10 people should cook in generally. And if 10 people are there and 20 people are cooking, again efficiency rise or down. What is your opinion? Or 10 person, 20 people cooking. What will happen? Again efficiency will rise. Because they will purchase for the same potato or same onion to cut. Because that has to divide between two persons. So work will decrease, okay? So this is the philosophy of supercomputer. You cannot get history just by increasing the work hour. So in the morning session or afternoon session, we heard from Professor earlier that how wide or let us say algorithm can beat the hardware. Okay? Can beat the hardware. A wide algorithm can be easily beat the hardware. Because if we adopt another software, we can do calculation in laptop, but if we adopt another software, we can do same calculation in the laptop. That means algorithm is more on the hierarchy than the actual computer hardware. Okay. So this is how the supercomputer is. And this is the whole card and train. They are in the history and other is the coordinated. Okay. That is how it makes difference between supercomputer and ordinary supercomputer. And we need supercomputer. Or at least Himachal Pradesh can make a state-wise supercomputing facility, let us say. So in that case, it will be LLC, Himachal Pradesh, LLC, Himachal Pradesh Supercomputing Center. Promotion of science, technology, and innovation. That is the first thing supercomputer. And creating jobs. Supercomputer will create jobs because just to manage supercomputer, we need some manpower. That is the expenditure we are putting on supercomputer. But it can serve many people, and they will be experts, and they can do some startup companies, and they can get jobs from other people. That is just the economic aspect, okay? And everywhere, job is very rare and difficult to get. And that will obviously develop the country. Cost reduction and data integrity of RNSI computing. I always emphasis on this part, RNSI computing. What does it mean is, like if India has a supercomputer in China, India uses Indian scientists, or engineers use a supercomputer in China, for example, okay? It may be not always true. For example, and all the data are there. Suppose even let us say more efficient. Indian missile design. Aerodynamics of the missile is working on a Chinese supercomputer, then definitely there is always risk of integrity of the design. Because the servers and hard drives are on the China and they can pick up inside your design and how it is being designed. So it will basically not that beneficial for the integrity of the country. So this is the current side computing. And same thing might happen in other cases also. And we develop the human resource, human capital. Generally, capital refers to money, but there is a capital called human capital also. And supercomputers produce human capital. Okay. and there is a philosophy, power of data, computing, and analysis. Because we have done so many DFT calculations, so many MP calculations to DFT, because computer evolved massively after 1990, and now 2023 means 33, not 33, 33 years has been passed of this high computing culture. So we have very huge amount of data, but equally now challenge is how to understand that result itself, because we have big results. So we need again supercomputer. Okay. So analysis, that is the analysis part. Supercomputer is a cutting-edge research. Although it is in native context, but in Indian context also it is equally valid. Training and education, this is the most important part of all the supercomputers in worldwide. And India and Nepal are no exception. Okay. Hands-on session, which we are doing some vertical or later today or tomorrow and after day. That is the hands-on session. And now I would like to put mind also, like all the others said earlier. Mind hands-on session. I put that the hardware, software, and low-level programming, like programming in math or programming in Mathematica is not low-level. They are high-level programming. Low-level programming is doing on C, Fortran, or assembly. The lowest language is assembly language. Okay, that is, there is no color sign in assembly language. You have to write yourself how to do clock. So there is no even clock. So that is the lowest level language. You have to accumulate data directly from the memory register. That is the lowest level programming. That can be done in this supercomputer. In grade game, we have many examples. Myself are example of grade game. Although I did not bring supercomputer while returning from the USA, but at least once I return, I try to make it in Nepal. That is a brain game. And in India, there are so many scientists and engineers, they have returned from abroad after finishing education. Or even they chose to finish their education right here and they went for job and later on they returned back again with some new knowledge, new thinking, and new perspective. So supercomputer gives a platform or a chance to return back to the country. Okay. If you are like internally in computing, then it is like addicted, computer addicted. So if you have no computing machines like you can sleep, you can eat. Okay, that is a computing addiction. I would like to say. So that is how if you have that machines in Nepal or India, then you will definitely return back and be more productive with those machines and algorithms. And supercomputer really challenge this kind of otherwise with the ordinary attention check how it goes. I mean, thank you. Although India has many supercomputers in like IITs and ISAs, but not in college like this. I haven't heard of this, maybe, but I'm not aware of. Okay. Just, I would like to show how the supercomputer looks like, what it can be done by a renowned scientist of public nation Adhikari. That is one of the highest labs in USA by the operated by US government. today we are announcing Frontier. It is going to be able to do 2,000 petaflops or 2 exaflops. This machine is going to change the world from medicine to biology to materials to deep space to climate change to energy transition. Oak Ridge National Laboratory works with the most difficult problems that humanity faces. Let me tell you how Frontier is going to help us all. In a pandemic, Frontier will allow us to take all the information based on data of the virus that we have already seen gathered globally. Put it up in the memory of this machine and look at what are the possible mutations or variants that you can expect, and we will be able to create drugs or create vaccines to combat pandemics in the future. That, to me, is exciting.
We would like to be able to predict our health 1 year from now, 5 years from now, 10 years from now. The computational models that we can build with this supercomputer will allow us to fill missing pieces in the puzzle of what is life. By understanding and modeling life, we will be able to develop new treatments and think about healthcare in transformative ways.
Think about a patient in an ICU who's got septicemia and they got 24 hours to live and they're not responding to any antibiotics. You don't have 6 weeks. Frontier is not only for speed's sake, but I would say it's speed for human sake because it allows us to create medicines much faster and deliver them in a more equitable manner so we can have massive impact. Frontier will allow us to understand how the world is going to evolve, shape the evolution for the better.
The simple way to think about it is that Frontier will give us a boost of acceleration by a factor of 8. Another way to look at this is that we will be able to tackle problems that are 8 times more complex in the same time.
Frontier will not be possible without a special partnership between HPE, AMD, and ORNL. But it's really about the people who are truly passionate about deep learning, artificial intelligence, and new science. Today, this machine is going to drive how the entire industry moves forward. I talk to our industrial partners, for example. They tell me that they're really excited because Frontier provides them with that ability to do an engineering design cycle within a finite amount of time. That's when we're doing real fine. Frontier is going to allow us to design even more efficient, cost-effective, reliable, and powerful wind turbines, which ultimately helps us be more sustainable in terms of our energy footprint globally. And that's really what this is about. It's like putting a superpower in the hands of your engineers around the world.
That is extremely rewarding, knowing that we're preparing the next generation. We give them the tools they need to make the next leap.
It moves the future toward us faster. There's just going to be an explosion of not only results, but an explosion of new questions. Ultimately, this achievement challenges each of us across all our industries to ask, what is the next frontier?
So this is, am I audible?
It's going to be an explosion in the future.
We're talking about
This is the case of America, which is considered the developed country in the world and most advanced technology they have. But we should not be feel inferior after seeing this video. But my plan is to encourage all of us to what supercomputer can do and why we have to adopt it in our development of science, technology, and economy at the same time. And one of the scientists here says this is the speed for human sake, not for competition, but human sake. Like there is a patient in a critical care unit. He has possibly not even 24 hours, as he said. He has 2 seconds. But if there is no antibiotic, all the failure, and what supercomputer can design health, that better antibiotic, custom design antibiotic, mostly even. So suppose we have corona vaccine, that was same for all, okay? But some vaccines didn't work for everyone because of different human anatomy and different type of reactions of our body to the foreign chemical. That is kind of chemical. So we have to custom design, and supercomputer can help patients to custom design those antibacterial or antiviral drugs. So this is what they are saying here. So this is a very interesting guide. And after this, let me go to the science part again. LUMI, large unified machine. This is called LUMI. Okay, let me play this LUMI as well. Oh, here it is. But anyway, I will go to, now I am back to India now. Meantime, my slide. Video is not loading, but I will do it here. Okay. Yeah. In order to tackle this kind of problem, we might need supercomputer. Okay. So here is the issue with my old laptop. That's old.
Even close it and then restart. And I think it will work.
Close
your PowerPoint presentation and then restart.
Okay. Maybe internet might help. This page is also fun. Anyway, let me try to go next slide. Internet is working. So if anyone of you connected to this college network, can you please disconnect the cell phones or any devices? Yeah. Let me do an article right here. is the one. Now let us talk about the room.
Is one of your HPC's flagship supercomputers. Accelerated supercomputer enables the convergence of high-performance computing, artificial intelligence, and high-performance data analytics. Logistic performance functions 550 and uses small partitions. The largest additional system is a consisting of GPU accelerated nodes using future generation AMD linked GPUs. In addition to this, a smaller CPU on a partition features third generation AMD linked CPUs. Its storage system, totaling 117 megabytes, consists of 3 layers. The memory takes up 150 square meters of floor space, which equals the size of a tennis court, and weighs 150,000 kilograms. The supercomputer will be placed in the CDC data center in Miami and hosted by the Lumi consortium. Lumi is powered using 100% hydro electricity, and its waste heat will cover 20% of Miami's annual district heating needs. When the operation starts in 2021, it will be one of the most competitive supercomputers in the world, providing HPC and AI resources for European researchers and academia and industry. Up to 20% of Lumi's resources are reserved for HPC.
So this was the LUMI, from the European consortium. So this is forum. Supercomputer in India was originally named as a forum series. The first was forum 800, I guess, in around 80. So by then it is evolving exponentially, in mostly in IITs, ISR, and government facilities such as BAR. Okay. Let us see this video. How India thinks about supercomputers.
Supercomputer विज्ञान और इंजीनियरिंग के विभिन्न क्षेत्रों में अनुसंधान और विकास कार्यों में तेजी लाने के लिए एक बहुत ही शक्तिशाली माध्यम है। माननीय प्रधानमंत्री श्री नरेंद्र मोदी जी के नेतृत्व में राष्ट्रीय सुपर कंप्यूटिंग मिशन भारत सरकार की महत्वपूर्ण पहल है। ये मिशन संयुक्त रूप से इलेक्ट्रॉनिक और सूचना प्रौद्योगिकी मंत्रालय एवं विज्ञान विज्ञान और प्रौद्योगिकी विभाग के मार्गदर्शन में सीलैब एवं IISC द्वारा वैज्ञानिक और अनुसंधान समुदाय की बढ़ती कंप्यूटिंग मांगों को पूरा करने के उद्देश्य से कार्यान्वित किया जा रहा है। इस परियोजना में भारत सरकार की वरिष्ठ अधिकारी जैसे कि नीति आयोग, IIT, JNU, DRDO आदि के वरिष्ठ विशेषज्ञों की भूमिका अहम रही है। इस परियोजना के तहत सीधा पर शिवाय सुपर कंप्यूटर का निर्माण एवं विकास किया गया है। कंप्यूटर क्षमता 833 टेरा एवं इसे IIT, PhD, भारत में स्थापित किया गया है। PhD, IIT में सुपर कंप्यूटिंग सेंटर की सुविधा में शुरू हुई है। सुपर कंप्यूटर की शुरुआत से नेशनल सुपर कंप्यूटिंग की गति मिलेगी। भारतीय संस्थान विषय द्वारा देश अनुसंधान और विकास को मजबूती प्रदान करेंगे। पर शिवाय सुपर कंप्यूटर 19 फरवरी 2019 को समर्पित किया गया है।
Now, this is the service NTIC. NTIC means it is actually going in planning on Nepal. That's clear, but India has the same planning as we just heard Prime Minister Modi as well. Computing. In Nepal, we have government data centers, but they lack computing. So we are trying to push them to improve the supercomputer and add one less block as a compute block. So that is particularly missing in this case. And how it might be as an inspirational slide, how we develop supercomputer in Nepal is like this. There is a government agreement between CERN and Nepal government by the Ministry of Science and Technology in 2017. And after this agreement, Kathmandu University and CERN has agreed particularly these two topics, research and educational training. That means all open science. Our supercomputer mission fully rely on or fully devoted to open science, not developing weapons, missiles, rocketry, or any other things, just open science, such as GFT calculation is open science, molecular dynamics is open science, designing drugs and vaccines are all open science. And this is the team in Switzerland. They have these two are the persons from CERN, Switzerland, and this is my friend, Dr. Suresh Shrestha, who is in USA Ohio right now. So he was then an employee in CERN and my friend, so he helped me a lot to coordinate with the CERN officials because I cannot tell them directly, or if I told from here, I don't know the exact scenario there. So you will even to write a one essence email, we usually sit for hours and hours so that very good wordings can be composed. So he helped me a lot for this purpose. And this is our team. We call it a super dozen, although few students are in here. And he is a professor of mechanical engineer. He is also mechanical, he is from computer engineering. And he is from environmental science and engineering. And he is a
networking staff and the most technical roles. And these three are the students in computer engineering, and here is myself in 2018. This photograph is taken in 2018 in our supercomputer room. So we are all volunteers, and in whole world, nobody can imagine a supercomputer center operated by volunteers. So we have developed a new economy, or economy without any cash, zero cash economy. How that is possible, I will tell you later. Obviously, volunteer means 90% of cash flow is gone with volunteering, and that is our 5 years achievement with a supercomputer. If there were no supercomputer, we were seriously concerned in our progress. 150 undergraduate students completed their final year projects, and 15 plus master's students and 5 PhD students are working with supercomputer. Carson University has 7 schools altogether. So out of 7, except School of Law and School of Management, they are not using supercomputer. All other schools are using supercomputer. And 50 plus publications and 100 plus citations with supercomputer within just 5 years. Actually, not even 5 years, 4 years of time. Because 1 year we spend on building and testing it, and operating in zero budget. We have no cash at all. We have no budget on supercomputer. And but we operate 24/7, 365. And facility upgrade. We are not those machines like Storm gave. By our own effort, around 22 lakhs of Nepalese rupees, we upgraded our storage to 60 terabytes, and we have to GPU processor that was around $7,000. So that was huge addition to the supercomputer. And our main mission was training. So that this is also training in a supercomputer. In fact, okay. So huge effort has been done, and volunteering hours, if we counted it, 150,000 volunteer hours has been spent. So therefore, it was possible without cash. It's a new kind of economy. We are in a like age economy. Give goods, take goods, no cash. So we extend the service, such as if a faculty wants to use our supercomputer, then we tell him or her to send 5 more students. She will organize workshop and train 20-50 students. So we will give like 10,000 hours of computing, and another person same. And if a vendor asks, we send them to give some commodities such as hard drive or SSDs, which are more faster, IO can be done on the machine, or air conditioning unit to the facility, and we use the facility. There is no cash, just goods. It's very interesting economy we have developed, because we have no cash and we have to go alternative, and we cannot stop our supercomputing, because I already told we are addicted to the computing. That was the reason. If you are addicted, you will do anything to get that substance, okay? So this is the same thing happening here. But for good part, not for bad. And next is our supercomputer has been used to combat COVID also during pandemic. And this is conducted by the School of Medicine at University. They contact tracing and home isolation server was made, and given training to government staff, making this kind of portal. And there are so many trainings going on. So in summary, this is the thing. Lesson learned. What we learned after teaching supercomputer for almost 5 years is like this. Apple University is capable of designing, building, and operating supercomputer. Supercomputer is innovative, economic, and sustainable. Sustainable in the sense that we are operating 5 years without a single rupee. That means it is sustainable, obviously. Our internet service is provided by a vendor. It
sponsored, and our electricity is sponsored by government and partially by university itself. So there is no cost of any supercomputer, and all the manpower are volunteer. And we also train supercomputer like this training. We do not take any cash as a company. Do not take any cash for supercomputer purpose. Okay? Although you might help my accommodation and going and coming, but that is volunteer. Yes. And supercomputer is digital revolution. In ancient times there was a revolution by weapons, but this time revolution can be done using supercomputer. Okay, if you take the history of all developed countries in Europe, Japan, and America, and Canada, they all have supercomputer, and even India is developed just because of the supercomputer. Just few weeks ago, I think, ISRO has developed a very nice rocket, and it was very nicely tested also, like this rocket. It was a reusable rocket, it is also made in India. That is all possible by supercomputer. Otherwise, we have to design and make the metal, and if that design is not working, that metal and effort gone waste. And again, we have to make another metal and design. If that is not working, then that is also wasted. But with the supercomputer, we can design very fine design and then go to the foundry to melt the metal or to part the metal, and that will, for sure, it will work. Okay, so that will save huge cost of those design. And increase also substantial increase. There are many kind of technological advantages that can be first tested in supercomputer, then to the actual field. Like earlier we talked about in vitro, like in field. Let us hear one word on that in field. We can do in field also. All three parts and then go to in field over. Otherwise, not go in field over, because that will be wastage of resources. This is the context of Nepal and might be useful in India also. And what I have example from India. This supercomputer is commissioned in 2014 just for agricultural calculation, not other calculation. And it is inaugurated by then Minister Sarad Pawar. So this kind of philosophy or thinking is very advanced, and India has to develop supercomputer dedicated for agriculture. Like Nepal, India is also has a lot of agricultural land and agricultural business. So a dedicated supercomputer is provided for agricultural calculation. Then no DFT can be done on that supercomputer, particularly assigned for this one. And in Himachal, the sources, there are so many dams. Actually, development of Himachal Pradesh started with the building dam in Sapat or other rivers, Kangla River, somewhere. So those dams and turbines can be designed using supercomputer. Now, and the speed of is huge. By then, it might take like 10 months to design a dam or turbine. Now we can do in 10 minutes using supercomputer. Okay? So that's it. And finance, another application of computational finance, share market, insurance, fraud activity like credit card fraud identification. There are so many applications in financial sector also. And geotechnical ancestry with hazard analysis. So a few days ago there was an earthquake in Afghanistan, and I have read the news that the effect was felt even up to Delhi. So although there was no damage in Delhi, but more damage in Afghanistan where it was the epicenter. So we can at least say in roughly give some estimate of earthquake. We cannot predict exact time and date, but a rough estimation can be done. Like this region is vulnerable for earthquake, that can be told in computing about. And medicine is no exception. Digital MRI, CT scan, and digital X-ray takes a lot of data and processing also. That can be done using supercomputer. And below there is a coronavirus, which we have all witnessed. Generally, building a vaccine from lab to army is 10 years, conventionally. And during that COVID time, we have seen that it is developed within a year. How that is possible? Because of the supercomputer.
And most of the US supercomputer and American supercomputer, even by private vendors such as NVIDIA, Amazon, and Microsoft Azure, they were liberally given to the scientists to work with corona calculator, so that design of the vaccine can be done very rapid at that time. And artificial intelligence is no exception. And this is a robot. I am also part of this mission called Nina, or female name in Nepal or India also. Nina. And she is a service robot, like physically challenged people and service in like restaurants or other places. People can order food and she will bring, or she can have service also for elderly and physically challenged person. She can understand Nepalese language very well. And national heritage. And Himachal Pradesh is particularly suitable for this purpose. So many indigenous languages, dialects, musical instruments, and song, music that can take the heart of anything because of the not promoting those we are all now globalization. We all talk Hindi, at least in our courses might be in Hindi. And our mother tongue is going to this area. So that can be stored and reconstructed using supercomputer. This is in a lump sum manner, let us say national heritage part. And there are many others, like maybe this is in Nepali language, but possibly you can read and understand partially. One is like a census, analysis of the census data, and weather forecasting, and climate change modeling, and hydrogen. There is very new addition in the fuel sector is hydrogen fuel. It is very inflammable fuel, but the problem is how to manage that fuel. And so people are trying to get better control over that fuel with the, and as a final word is that development of country, big pillar or strong pillar of the country's development. And why we should invest on supercomputer is like Himachal Pradesh also can make out its own supercomputer. Okay. Although I am not sure about Himachal Pradesh education policy, but this is from Nepal. So this is the background of it, and I have highlighted those areas. Anyway, I emphasize on the new technologies, emerging technologies, that would be a supercomputer. Okay? And we have figures shown. Now finally I will show you this figure. And maybe more than me you are familiar about it, and who are from Punjab, Haryana, you are the best person to understand this figure. Which is called, I would say, national kitchen. Because many people eat on the same kitchen, and here is the serving place, and this is the cooking kitchen. So supercomputer is like this. Why do we do this kind of food serving? Because of cost sharing. So that there are 100 people, and if we make 10 people for one kitchen, that is huge cost. Because for 100 people or even for 1,000 people, if our pot is bigger, we can make a single kitchen. Okay, that is a national kitchen center or the cost sharing. The supercomputer is the same thing. Like here, this college had one supercomputer, Umar had another supercomputer, or Simla had another supercomputer, or other colleges had their own supercomputer. That is costly, very costly in terms of operational management and user support. Although that is very special for tier 2 resources or tier 3 resources, and but for several supercomputer we must have for the cost efficient and very powerful calculator that cannot be handled by a university level supercomputer. So this is partly a financial modality, but we can take knowledge and do in future. You can do, you are from Himachal mostly. You can do in Himachal this session, which I have in vision, and Professor Adhikari has in a lot of this. Hardware, initial hardware and infrastructure or university cannot make effort for this. Okay. So it should be a government part. And operational management can be done by the university or colleges or even by users. And you can make some plans like a 5-year plan to persuade the authorities. And final thought is that supercomputer opens doors for immense possibilities, and we are engaged by our imagination. And era of supercomputer started in India in 1980, but in Nepal just 4 years ago. And India has women supercomputer. And this is little bit technical, but you can remember this idea how supercomputer is technically look like. We have different varieties of resources in supercomputer. One tomorrow you will experience it. One is called head node, and another is called service node, another is called storage node. And there are varieties of these are the compute nodes are also not same, but they are different varieties. One is like faster clock, more clock, high memory, and GPU. Okay. Like I have told you in the second slide, in a rice planting field, some are planting, some are picking rice from the nursery, some are digging, some are just distributing those packs of rices. Okay. So this is the same kind of coordination. We make a supercomputer. And I am showing the real hardware. What I use for the supercomputer is the hardware component. This is Ethernet. Actually, I don't say Ethernet. It is a adapter. In our laptop, where you plug in a wire or networking, it is around 1 Gbps wire, or mostly available in 100 Mbps. But in supercomputer, node-to-node communication is 200 Gbps. That means use faster. Okay, 100 or 1000 times faster. And another is switch. Like we have a router in our home. This is a kind of router in supercomputer. It has many ports, not only ports like our home router, but many, even 100 or depending upon the need. And on the right side there is a cable, networking cable. It is different called fiber. Might possibly you are familiar. This is the actual server that used in a computing part. And GPU, finally the GPU. Okay, GPU looks like on the left side, and the actual GPU server is on the right side. So these are the stack server with their history, and this is the next GPU that this is Quadro and this is Titan. And by the way, we have the same GPU that I was awarded by NVIDIA, and I donated to Tata University Supercomputer, and that was around 7,000 USD. Although this business is expensive, let us say, the business is expensive, but it is worthwhile to do. Why? Because I have shown so many evidences. What are the benefits of using supercomputer, and particularly on the side of the frontier they are talking. And in supercomputer, this is software part. That was the hardware part. Software is all open source. No need to worry now. Open source software we are using. Although there are commercial software, but that is not needed. Even for American government use open source software for supercomputer. Okay. This is Clodum. The full form is I forgot to write. Simple Linux Utility Resource Manager. And this software is open source, but we have to write the policy file in our report. Okay. Policy file means which jobs run faster, which user has how many controls on CPU, how many controls on GPU, how many memory he can take, how many storage he can take at once. Those are the policy we have defined here. And another is Lecture. This is a parallel file system software. And architecture is I have, although you may not understand right away, but you can read further. At least I am making you aware of these platforms. And next is cache. Cache means bitly, but in Hindi it is called bitly, or Nepali it is called Trialo. This figure looks like a cache. Okay. The cache has full form like this. Extreme cloud administration toolkit. That is called cache. Okay. Unknown cache. And this is my final slide for the supercomputer part. What this is on the left side, silkworm. Do you have mulberry in Himachal? Because its altitude is very similar to Kathmandu and Kathmandu University. Mulberry. How many of you are familiar with mulberry? Okay, good. Mulberry is a plant. Generally, it fruits right in this season, April, May, or it started from or the later like March also, late March also. Okay. So this is the larva of the silkworm. They will eat those leaves of the mulberry. And what is the product? Silk. Silk is a very expensive cloth. Although I do not like killing animals for our good clothes. And in the next side, there is mostly non-violent production. This both is live in some sense, and this will give milk that will give chips. And supercomputer, investing on supercomputer is same like you invest very little, and the sense is like that. You invest very little and you get all out. And I will give you one example. Suppose we have a road, like a 100-year-old road, which is like on a very much foggy road, 100 years old. We can do that, we can conventionally keep on driving on those roads because it is strong and no need to modify engineering. But if you modify and attempt to make the road slightly straight, investing few million currency, Indian currency, that is what I should do because it saves oil. It shortens the route and decreases the oil consumption. And that investing on grid will easily recoverable in 1 year. If you keep on driving on those quality roads for many years, actually you are you are wasting money. So supercomputer is like this. Like constructing roads, constructing house, because they will return eventually, like Professor said earlier. What is the use of newborn baby? It has no use. But we don't know what he will be later on. He will be Samrat also, he will be Chandragupta Maurya, or he will be anyone who has done a lot of like imperial, let us say imperial, although it is like more conventional word, but he could be an imperial. But at the time of he was born, nobody knows what he will be. Supercomputer puts the same effort and science puts the same effort. So this is how it is worthwhile to explain on computing. This is now finally I will close this by not saying super, just by computing. Let us develop a computing culture. It is not only hardware, it is our thought and algorithm that makes it. It's super. When you put those two things on the computing, it will be just supercomputing. It is not just by hardware. Okay. Thank you very much. And so shall I present deep learning part as well? Or if we want to discuss the break first to 5 minute break, that is also. I have one more slide remaining. But
I think we will meet after tea, right?
Yeah. That is what I have. In the meantime, if you have some questions.
Any questions? What is the difference between learned script and previous scripts about they differ from each other? And what are the other scripts that they can use in supercomputer?
Yeah, I think there is not much difference. It is a preference only. But as I am habitual to learn simple Linux utility resource manager, I spent around 15 years on Scala. So now it is very difficult for me to switch on C here. Although I work on C here, but not that much. So while building supercomputer at Kathmandu University, I chose Scala. Although I tried CVS as well, but later on I didn't like that one. And it is more user friendly and in some sense preference as well. any other questions or
No question. So I think we have to move for tea break, and after that, we will again gather here.
next session